Dear students, this video I am sending to you for the experiment number 3 of survey practical. The object of this practical is to determine the gradient of AB line using stadia method. Now here the figure which I am showing to you is the elevation of a building, and A point is the top of the building and B point is the opposite point of that building on the ground. The horizontal distance between these 2 points is D and the vertical distance between these 2 points A and B is V. Now to find out the gradient of line joining points A and B, you need to have the vertical distance as well as horizontal distance. And the beauty of this method is that you have to find out all these distances standing from one point, and no distance will be measured by tape or chain. It will not be used. Only by the use of tachometry you have to find out all the distances. One tachometer or a theodolite will be given to you, and you will station that theodolite at some distance from this building. Now I am showing you the scheme of this experiment, how this experiment will be performed. So this is the diagram of operation of this practical. The point A, I think, is visible to you. This is the top of the building, and this point B is at the ground. The distance you can see here between these 2 points, horizontal distance, you can call it D or H also you can call. And what will be the vertical distance? Vertical distance will be the difference of RL of point A and point B. That will give you the vertical distance. Now, how you will apply the tachometric formula and what observations you have to take, this you have to see from this figure. Now you see this point O, I can show you here this point O. This point O, this is the point where you will put your instrument, where you will fix your instrument, theodolite. After making the temporary adjustments of the theodolite, centering, leveling, etc., you will make the horizontal circle 0, 0, and then you will point your telescope at a staff that will be kept at the top of this building. This is the top point of the building. Here one leveling staff will be fixed. So you will see through that telescope this staff, and you will find 3 staff intercepts. This is top, middle and then lower intercept. तो ये तीनों रीडिंग्स आप यहाँ पर स्टाफ इंटरसेप्ट की आप नोट करेंगे. After that you will turn your telescope towards point B. जब आपने यहाँ पर रीडिंग ली थी, टेलीस्कोप ऊपर की तरफ था, तो आपने वर्टिकल एंगल की रीडिंग नोट कर ली. Here you will record the reading on the vertical circle to get the vertical angle between point O and point A. After taking the vertical angle, you will rotate the telescope here. Now at the point A, the horizontal circle was at 0, 0 that you have done earlier. Now you will unclamp the upper plate and clamp the lower plate, unclamp the upper plate and turn the telescope towards point B. That will give you the angle theta. This is the horizontal angle between point A and B. And at point B, another staff will be erected here. It will be fixed here. So you will make the telescope of the theodolite at 0 0. Vertical means vertical angle you will make 0 to make the telescope in horizontal direction. Now once the telescope has been fixed in horizontal direction, you will note down the stadia wire reading here. Again you will note the 3 readings of the stadia wire. Okay, so after recording these readings, this you will do when the theodolite is in face left position. Okay, and after recording these readings, again you will take these readings with face right position. So for taking the same readings by face right position of the theodolite, what you have to do, you have to again bring the telescope with the horizontal circle at 0 0, and then you will coincide this reading of the staff which was at the center of the staff. सेंटर पर जो आपने रीडिंग ली थी उसी रीडिंग को आपको वापस वहीं पर लाना होगा, टेलीस्कोप का जो सेंट्रल वायर होता है वहीं पे लाना होगा, ताकि आपका वर्टिकल जो एंगल यहाँ से बना है, जो पहले बना था वही एंगल बने, उससे फर्क ना हो. तो ये रीडिंग आपको सेम जो सेंट्रल स्टेडिया रीडिंग आपने जहाँ पर आपने ली थी, बिल्कुल उसी पोजीशन पर आपको सेंट्रल स्टेडिया वायर यहीं पर आपको फिक्स करना होगा थियोडोलाइट का. उसके बाद आपको ये सारा काम रिपीट करना होगा, मतलब ये एंगल थीटा लेना होगा और फिर यहाँ पर अगेन यू हैव टू टेक द स्टाफ इंटरसेप्ट एट बी. नाउ यू सी द फॉर्मूला. अब देखिए ये एक डिस्टेंस, द डिस्टेंस ऑफ द स्टेशन, इंस्ट्रूमेंट स्टेशन फ्रॉम पॉइंट ए is d1 and the distance of instrument station from point B is d2. How you will find d1 d2? This is the formula for d1 and d2. Understand? This is the tachometric formula. This k is the multiplying constant, SA is the staff intercept, alpha a is the vertical angle which you have taken for point A, the top of the building. Okay, alpha a, c cos alpha. This formula you will use for this distance d1. Thereafter for distance d2, this distance you will use the very simple formula, because here the angle is 0, so ks plus c, the formula of tachometry that you know very well, that you will use to find out this distance d2. Now this VA is the formula to find out the vertical distance. VA, this you can see here, this is the distance above the line of sight of the instrument to the central wire reading of the tachometer at the staff that you have taken. यहाँ से यहाँ तक का जो डिस्टेंस है ये VA कहलाएगा, और VA आप कैसे निकालेंगे? इस फॉर्मूले से निकालेंगे. K is same. Now instead of alpha a, here it will be twice alpha a upon 2, and this sign, and here again sign. So this formula you will use to find out VA. Then a cos formula, you know, cos theta is equal to this much. Here in this formula you know this theta angle. So cos theta you know, and d1 and d2 you have just find out using these formula by tachometry. And here in this equation d is unknown, this d, the distance between point A and B. Understand? So this unknown d you can find out from this equation. So the horizontal distance is known to you. Now you have to find out the vertical distance between point A, this point, and this point B. So how you will find it out? So here you see an equation is been given to you. RL of B plus HB plus VA minus HA is equal to RL of A. Now see the figure. RL of B plus HB. This is the RL of B plus HB. If you add HB to RL of B, you will reach the height of instrument. Now the height of instrument is here, is touching this point where VA is coming. Okay. Now you add VA to it, you will reach the central wire reading of the tachometer. And if you subtract from this point HA, you will reach the RL of A. इस तरीके से आपको RL of A मिलेगा. देखिए, this is equal to RL of A. Now we will rearrange this equation like this. इसको rearrange करेंगे. RL of A minus RL of B, उसको इधर ले आए, RL of B को, तो ये हो गया VA minus HA plus HB. So RL of A minus RL of B, we can write V. We can write here V. So the V, or the vertical distance, you can calculate like this. Okay. Now once you have got the vertical distance, the horizontal distance D or H you are already having, so you can find out the gradient of the line AB. Okay. Gradient of line AB will be equal to tan theta will be equal to V upon H, or 1 upon H upon V. So it will be 1 in this much, whatever the value it comes. So this is the shape of the figure of this building. In this way you can find out the slope of line AB. Here you have got V and H. So H upon V, that will give you the gradient of line AB. I hope you have understood the problem.